First of all, I welcome all the students and the participants who are attending this live lecture. Today in this live lecture we shall study some applications based on the Riemann sum. That means we have to study some theorems which are based on the Riemann sum, Actually, this is the lecture number 11. Now we shall start this. Here, Saili Kale, Yogesh Wagmare, some important applications. We have to study some important applications. Before starting the some important application, I shall revise the concept of integral as a limit of sum, or we can say that Riemann sum. The definition of the Riemann sum is S of p comma f is equals to summation I is equals to 1 to n f of ti into delta xi. That means f of ti is replaced here in the form of capital Mi and capital small mi replaced by f of ti, which is as shown in the figure. So already I have expressed this concept detailed. See here, this is the upper sum, this is the lower sum, this is the Riemann sum. Okay, these are the concept already we have seen. Also we have seen the definition of the integrability, second definition of the integrability. First definition of the integrability is a totally depend on the lower sum and upper sum by using the L of p comma f. U of p comma f we can define the condition of the integrability, that is also called as a Darboux condition of the integrability. So here this is the second definition of integrability, which is depend on the Riemann sum. This is very important definition. This is the definition regarding the Riemann sum. A function f is said to be integrable on closed interval a b if limit S of p comma f exists as mu of p tends to 0, then limit mu of p tends to 0 S of p comma f, which is equals to integral from a to b f dx. Okay, this is the first condition of the integrability, and this is the second definition of the integrability, which is based on the Riemann sum. Okay, these are the Darboux condition of the integrability. This is also the definition of the integral in the form of a modulus. For epsilon, for any epsilon greater than 0, there exists delta greater than 0 such that norm is less than or mesh is less than delta, then the mod summation I is equals to 1 to n p of f of ti into delta xi minus integral from a to b f dx, or it is also denoted by याला असं सुद्धा लिहितात mod of S of p comma f minus integral from a to b f dx, which is less than delta. We can write this as also. Also, this is the second definition. This is another definition for the integrability of a function. Now we shall discuss some important theorems. निर्मोही देशमुख, संस्कृति, दर्शन गोरे, उपरवाड, सीमा ठाकुर, सोनोने, पवार, शिवानी. ओके, मी क्वेश्चन विचारलं तर प्रत्येकाने आन्सर द्यायचं, लक्षात घ्या. ठीक आहे. नाउ वी शॅल स्टडी द थिअरम वन बाय वन. ओके, some important applications. The first application is number 1, First application, or we can say it is a theorem also, if f1 comma f2 f comma f1 comma f2 are be the functions such that f is equals to f1 plus f2, f1 plus f2 are bounded and integrable on closed interval AB, are bounded and integrable on closed interval AB, then prove that what we have to prove, integral from a to b f dx, which is equals to integral from a to b f1 dx plus integral from a to b f2 dx. As like the theorem which we have seen, देखो अभी actually we have seen the theorem as like addition theorem. We have seen in the first unit or in the first part we have seen this theorem. अगर यहाँ पे f1, f2 and f are the three functions such that f is the addition of f1 plus f2, f is the addition of f1 plus f2 which are bounded and integrable, f1 and f2 are the bounded and integrable, then we have to prove that f is also bounded and integrable such that integral from a to b f dx, which is equals to integral from a to b f1 dx plus integral of a to b f2 dx. Okay. Now we shall start the proof. Similarly, theorem can use for way to see this. Proof. Given that the functions f1 and f2 are bounded and integrable, then by the definition of the integrability, for given epsilon greater than 0, there exists delta greater than 0 such that for any partition, this is the definition, for any partition, for any partition P which is equals to x naught x1 dot 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 xn with norm mu of P less than delta for every choice of point Ti in delta xi such that how we can write mod of summation I is equals to 1 to n f1 of ti into delta xi minus integral from a to b f1 dx, which is less than epsilon by 2. f1 is integrable, then we can write this. Okay. Similarly, f2 is also integrable, so and mod of summation I is equals to 1 to n f2 of ti into delta xi minus integral from a to b f2 dx, which is less than epsilon by 2. Suppose this is equation number 1. According to the, suppose this is equation number 1, this is equation number 2, that means f1 and f2 are the integrable function. Then according to the definition of the Riemann sum of the integrable function, we can write the both equation. This is equation number first, equation number second. Equation number first and equation number second. Now here we can write this. Now we have to prove that f1 plus f2, that is denoted by f. f1 plus f2 is also integrable. Now see this, now mod of summation I is equals to 1 to n, see this, that is f1 plus f2 of ti into delta xi minus again in integral from a to b f1 dx plus integral from a to b f2 dx, bracket close. The value of this integral becomes, that can be written as, which is equals to, now we can write the separate this, that is a summation over I is equals to 1 to n f of ti into delta xi plus summation I is equals to 1 to n f1, see this, f1, f2 of ti into delta xi minus integral from a to b f1 dx minus integral from a to b f2 dx. See this. Now we shall take this, these two terms are in a bracket, that can be written as in a bracket summation I is equals to 1 to n f1 of ti into delta xi minus integral from a to b f1 dx, bracket close, plus summation I is equals to 1 to n f2 of ti into delta xi minus integral from a to b f2 dx. This is mod close. Now we have to use the property. What is that property here? Mod of a plus b, which is always less than or equals to mod a plus mod b. ही प्रॉपर्टी आपल्याला वापरायची आहे मॉड्युलसची. mod a plus b which is always less than or equals to mod a plus mod b. ते सर्वांनी चॅट बॉक्स मध्ये मॉड ए मायनस बी ची प्रॉपर्टी लिहायची. काय असतं लिहायचे, सर्वांनी लिहायचे. मॉड ए मायनस बी मीन्स मॉड ए मायनस मॉड बी. पण लेस दॅन असतं का ग्रेटर दॅन असतं, चॅट बॉक्समध्ये सर्वांनी लिहायचे. आणि या आन्सरवरनं मी प्रेझेंटी घेणार आहे ऋतुजा मद्रेवर. सर्वांनी या क्वेश्चनचा आन्सर दिल्यानंतर त्याचे स्क्रीनशॉट घे, माझ्याकडे पाठव. कारण आपल्याकडे 100 विद्यार्थी आहेत, फक्त 20 विद्यार्थी लेक्चर करतात. बाकीचे प्रेझेंटी टाकून जातात. त्यामुळं त्यांना मी 4th सेमिस्टरचं हॉल तिकीट देणार नाही. तर ते विद्यार्थी फाइंड आउट करायचे, तर स्क्रीनशॉट घे. सर्वांनी याचा आन्सर लिहा रे. ठीक आहे. अभी देखो, दिस इज सपोज मॉड ए प्लस mod of a plus b, so we can write this as mod a means summation I is equals to 1 to n f1 of ti into delta xi minus integral from a to b f1 of f1 dx plus mod of integral summation I is equals to 1 to n f2 of ti into delta xi minus integral from a to b f2 dx. But from equation 1 and 2, see this, the value of this modulus is less than epsilon by 2, modulus of f2 value is less than or epsilon by 2. So this is a less than epsilon by 2 plus epsilon by 2. This is the less than epsilon by 2 plus epsilon by 2 means the value of this, that is so we get, this is from 1 and 2, from 1 and 2. So this implies that summation mod of summation I is equals to 1 to n f1 plus f2 of xti into delta xi minus integral from a to b f1 dx plus integral from a to b f2 dx. This value is less than epsilon because epsilon by 2. Put this left side is as it is. ये देखो ये लेफ्ट साइड as it is है. खाली उसको हमने सॉल्यूशन इस तरह से ले लिया है. उसका सॉल्व इसी तरह से करने के बाद हमें ये रिजल्ट आ गया. This implies that, अभी इसका मीनिंग यही होता है. This implies that what we can say, integral from a to b f1 plus f2 dx which is equals to integral from a to b f1 dx plus integral from a to b f2 dx. But f1 plus f2 is denoted by f. So we can write integral from a to b f dx which is equals to integral from a to b f1 dx plus integral from a to b f2 dx. And hence proved. चला रे, जे प्रेझेंट आहेत का नाही तर प्रेझेंट. मी काय विचारलं होतं रे स्टुडंट्स. हां, सर्व विद्यार्थ्यांना सूचना आहे. म्हणजे याचा अर्थ राहुल माहीत नाही, तुम्ही पण नाहीत. कोण आहेत ऑनलाईन, कोण आहे? सायली काळे, ऋतुजा देशमुख असते. ऋतुजा देशमुख आहे का? पृथ्वीराज जाधव आहे का? हां, सर्वांनी प्रेझेंटी द्या रे स्टुडंट्स. जे विद्यार्थी ऑनलाईन लेक्चर करतात ना, सर्वांनी प्रेझेंटी द्या. सर्वांनी प्रेझेंटी द्या, यस म्हणून द्या आणि त्याची स्क्रीनशॉट काढा. चला स्क्रीनशॉट काढो. कोण काढतंय? साक्षी चाकूरकर प्रेझेंट असते. ते स्क्रीनशॉट काढायची सर्वांची, ठीक आहे, आणि मला पाठवून द्यायचे. 21 विद्यार्थी त्यांनी प्रेझेंट टी म्हणून लिहायचं आणि स्क्रीनशॉट मला पाठवून द्यायचे. ठीक आहे. हां, आता सेम थेरम यू हॅव टू प्रूव्ह फॉर द निगेटिव्ह. मायनससाठी सेम थेरम तुम्ही प्रूव्ह करायचे. तो आय शॅल राईट दॅट थेरम. मी तुम्हाला ते होमवर्कसाठी देतो. सर्व सेम आहे, फक्त मायनसचा थेरम आहे. सो सेकंड थेरम, इफ F1 F comma F1 comma F2 be the functions such that F is equals to F1 minus F2 is bounded and integrable. Bounded and integrable. Then prove that what we have to prove? Then we have to prove that integral from a to b f dx, which is equals to integral from a to b f1 dx minus integral from a to b f2 dx. Same you have to prove this theorem. सर्वांना हा सेम थेरम प्रूव्ह करायचे. नो प्रॉब्लेम. नाउ थर्ड थेरम, थर्ड कंडिशन, इफ F1 and F2 belongs to R, F1 comma F2 belongs to R over closed interval AB, and C1 comma C2 are any two constants, then prove that C1 F1 plus C2 F2 is also belongs to R, and integral from A to B C1 F1 plus C2 F2 dx, which is equals to C1 integral from A to B F1 dx plus C2 integral from A to B F2 dx. Okay, now we have to prove this theorem. बहुत simple theorem है. We can prove this theorem according to the same process. Now proof. Proof. अरे तुमचा रिप्लाय कसं येत नाही? साक्षी चाकूरकर, सीमा ठाकूर, आवाज येतो का? काय अडचण आहे का? सांगा बरं रे. सीमा ठाकूर, चाकूरकर, पृथ्वीराज, आवाज येतो का रे सर्वांना? मला इकडं चॅट बॉक्समध्ये तुमचा रिप्लाय दिसत नाही आहे. ठीक आहे, आय शॅल प्रूव्ह दिस. लेट F is equals to C1 F1 plus C2 F2 for any partition P. We can write S of P comma F according to the definition, which is equals to summation I is equals to 1 to n f of ti into delta xi. Okay, so f means what? Actually f means C1 F1 plus C2 F2, so we can write this as summation I is equals to 1 to n. F means we can write C1 F1 of T1 plus C2 F2 of Ti, suppose, into delta Xi, because in place of F we have replaced C1 F1 plus C2 F2, C1 F1 plus C2 F2 of into delta Xi. So we can write this as, you now separate this, which is equals to summation I is equals to 1 to n C1 F of Ti into delta Xi plus summation I is equals to 1 to n C2, this is F1, this is F2 Ti into delta Xi. But C1, C2 are the constants. We can take out of the summation. C1 is equals to summation I is equals to 1 to n F1 of Ti into delta Xi plus C2 into summation I is equals to 1 to n F2 of Ti into delta Xi. But this can be written as a C1. This is the definition of S of P comma F1 plus C2 into, again this is the definition of S of P comma F2. So we get the result S of P comma F, which is equals to C1 S of P comma F1 plus C2 S of P comma F2. Suppose this is equation number 1. We have proved this result. According to our supposition F is equals to C1 F1 plus C2 F2, we can write S of P comma F is equals to C1 S of P comma F1 plus C2 S of P comma F2. आवाज येतो का रे? काय अडचण आहे? तुम्हाला आवाज येतो का नाही? हॅलो, तुमचं चॅट बॉक्स का चालत नाही रे? हां ठीक आहे, ह्याचा स्क्रीनशॉट घ्या. जे प्रेझेंटी दिलेले आहेत ना यस म्हणून तेवढ्याचे स्क्रीनशॉट घ्या. ओके, हे समजलं का रे? फर्स्ट पार्ट कसा आला? If we consider F is equals to C1 F1 plus C2 F2, then S of P comma F वरनं C1 S of P comma F1 plus C2 S of P comma F, हे कसं आलं? समजलं का तुम्हाला? ओके, नाउ we shall move towards okay, now we shall move towards the main problem. What is that? Actually we have given that the functions f1 and f2 are the integrable functions. See this, we have given f1 and f2 are the two bounded and integrable functions. Then we have to prove this result. Okay, इथं इंटिग्रेबल राहिला वाटतं, बाउंडेड क्लोज इंटरवल अँड इंटिग्रेबल. इथं इंटिग्रेबल टाका, इंटिग्रेबल फंक्शन्स कॉमा C1 C2 are two constants. Okay, now we move towards the integrability condition. Given that, see this, given that f1 and f2 are integrable. So according to the definition, so by the definition we can write mod of S of P comma f1 minus integral from a to b f1 dx, which is less than epsilon. Okay, so and mod of S of P comma F2 minus integral from A to B F2 dx, which is less than epsilon. See this. Suppose this is the second, this is the third, but we know that F1 and F2 are the integrable, C1 and C2 are the constants, so we can write therefore now integral from mod of S of P comma F minus mod of S of P comma F minus integral from A to B C1 F1 plus C2 F2 dx, which is equals to, we can write mod of S of P comma F minus C1, see this C1 integral from A to B F1 dx minus C2 integral from A to B F2 dx. But we can say this, C1 integral from A to B F dx हा जो S of P comma F आहे पहा, S of P comma F can be written as C1 S of P comma F plus C2 S of P comma F. So C1 is the common, so we get this result as which is less than or equals to C1 epsilon plus C2 epsilon from 1 and 2. So हे कसं केलं लक्षात आलं का? नाही तर एखादी स्टेप वाढवू का मी? ठीक आहे, मी स्टेप वाढवतो, वाटलं तर तुम्हाला नाही लक्षात येणार. फ्रॉम इक्वेशन 1 असं करतो, एक मिनिट, एक स्टेपच वाढवतो, तुम्हाला हे डायरेक्ट नाही समजणार कसं आलं ते. which is equals to from 1, what is that? C1 S of P comma F1 plus C2 S of P comma F2 minus C1 integral from A to B F1 dx minus C2 integral from A to B F2 dx. काय केलं इथं रिप्लेस केला याला, कारण त्या फ्रॉम 1 सिन्स मध्ये लिहा, फ्रॉम 1 वरनं लिहिलं. नाउ दॅट कॅन बी रिटन एज, नाउ वी कॅन कन्वर्ट दिस. इथं आणि इथं C1 कॉमन काढा, C1 इन अ ब्रॅकेट S of P comma F1 minus integral from A to B F1 dx plus C2 कॉमन काढा, S of P comma F2 minus integral from A to B F2 dx. काय केलं रे, इथनं आणि इथनं C1 कॉमन काढला, इथून C2 कॉमन काढला. आता परत प्रॉपर्टी वापरा. You know that what is the property? Mod of A plus B, which is less than or equals to mod A plus mod B. So this is can be written as which is less than or equals to, we can write C1 into mod of S of P comma F1 minus integral from A to B F1 dx plus C2 into mod of S of P comma F2 minus integral from A to B F2 dx. अभी देखो, from equation 1 we can put the value of this modulus which is less than C1 epsilon plus C2 epsilon from 2 and 3. Thus we get So we get, therefore, mod of S of P comma F minus C1, what we have given, minus integral from, yes, minus integral from A to B, C1 F1 plus C2 F2 dx, which is less than epsilon, and this proves that, this implies that integral from A to B, C1 F1 plus C2 F2 dx, which is equals to C1 integral from A to B F1 dx plus C2 integral from A to B F2 dx. But this is also F, so we can write integral from A to B F dx, which is equals to C1 integral from A to B F1 dx plus C2 integral from A to B F2 dx. And we can prove, and hence proved. अशा पद्धतीने हे दोन्ही थेरम होतात. लक्षात घ्या स्टुडंट्स, अशा पद्धतीने हे दोन्ही थेरम होतात. सो वी कॅन प्रूव्ह दिस थेरम. अशा पद्धतीने हे दोन थेरम झाले. नाउ वी शॅल प्रूव्ह द थर्ड थेरम. आता आणखी एक आहे तिसरा थेरम, जो आपण तिसरा थेरम उद्याला प्रूव्ह करू. इंटिग्रल फ्रॉम ए टू बी, बी टू सी, सी टू ए जो आहे तो आपण उद्याला प्रूव्ह करू. या ठिकाणी आज थांबू. आता कंटिन्युअस आपले लेक्चर्स ऑनलाईन पद्धतीनेच होतील. जे प्रत्येकाने एक सूचना आहे पहा, आपले सर्व लेक्चर्स ऑनलाईन पद्धतीनेच होतील. कोरोनाचा वाढतोय त्यामुळे 9 ते 10 रोज आपला ऑनलाईन लेक्चर होतील. दुसरं महत्त्वाचं, सोमवारपासून तुमचे प्रॅक्टिकल असतील. थेरी पिरियड मात्र ऑनलाईन ऑफलाईन होतील. तुम्हाला जसं सोयीस्कर होतील तसं पद्धतीनं करायचं. क्लासमध्ये गर्दी होऊ नये म्हणून ते ऑनलाईन ऑफलाईन होतील. आणि सोमवारपासून प्रॅक्टिकलच्या बॅचेस छोट्या छोट्या असतात त्यामुळे ते ऑफलाईन होतील. सर्वांनी जास्तीत जास्त प्रॅक्टिकल करण्याचा प्रयत्न करा. काहींना अडचण असतील, गावाकडे असतील तर त्यांनी मग कधी तर मग प्रॅक्टिकलचं तुम्ही ॲडजस्टमेंट कसं करायचं ते करा. कारण आपल्याला एप्रिल महिन्यामध्ये म्हणजे 15 मे पर्यंत सर्व प्रॅक्टिकल्स सुद्धा संपवायचे आहेत. तर अशा पद्धतीनं तुम्ही पण तयारी करा. आता मॅथचं प्रॅक्टिकल, SCCचं तेवढं प्रॅक्टिकल आहे. तुम्ही जसं वेळ भेटेल तसं तुम्ही मॅथ लॅबमध्ये येऊन ते SCCचे प्रॅक्टिकल करा. ओके. नाउ